Current is a flow of charges. A current flowing through a straight wire creates a magnetic field around it. When the current flows into the page by using right-hand grip rule, we can determine that the direction of the magnetic field is clockwise. When the current flows out of a page by using right-hand grip rule, we can determine that the direction of magnetic field is anti-clockwise. Current is directly proportional to the magnetic field. When current increases, the magnetic field also increases. Distance is inversely proportional to the magnetic field. When the distance increases, the magnetic field increases. R is the distance from the conductor to any desirable point. For example, from the conductor to point C. Magnetic field at point A is stronger than point B.
This shows a circular loop that has current flowing through it. Imagine your thumb as the direction of current flow and the rest of your fingers as the magnetic field direction. Using the right-hand grip rule, grip the circular loop with your thumb facing the same direction at all locations. Notice how the magnetic field is always pointing at the same direction. Now, we know that at any point of a current flow, the direction of magnetic field will be the same so long as the direction flow of current also remains the same. Now, I'm going to teach you another way of finding the direction of magnetic field. While still using the right-hand grip rule, imagine your thumb as the direction of magnetic field and the rest of your fingers as the direction of current flow. Curl or grip your fingers along the circular loop, and you will notice that your thumb will always face the same direction. This shows the direction of magnetic field. Both methods are free for you to use to your own comfort. Reminder that the magnetic field that will be calculated is only at the center.
Unity is what we have learned just now. The formula for the magnetic field at the center of a current-carrying circular loop is B equals to mu naught times N times I over 2R, where B refers to the magnetic field strength at the center of the loop, and the unit for this is Tesla. Mu naught, which is a constant, refers to the permeability of free space, and its value is given here. The unit for this constant is Tesla meter per ampere. N is the number of loops. I refers to the current in the loop measured in ampere, and R is the radius of the loop measured in meters, which we can determine by measuring the distance from the center of the loop until here. From the formula, we can see that B is directly proportional to I and inversely proportional to R. So this means that when the I increase, the B will increase, and when the R increase, the B will decrease.
Next, we will talk about the solenoid.
The finger is considered as the direction of the current, while the thumb is used as the direction of the knot. As we can see, the current is going up. Thus, our finger will also follow the direction of the current. Automatically, our thumb will be pointing at the knot, which is pointing to the left. Then, we all know that the magnetic field from north poles pointed towards south. The magnetic field will enter the south and going out from the knot. The opposite thing will happen when the current is going down.
At the center, we will use this formula to find the magnetic field, while the magnetic field at the end of the solenoid, we will use this formula.